Welcome to the notes on finding area of regular polygons. And that's our goal today, is to calculate the area of those regular polygons. Remember, regular polygons mean same size, same side, and same angles. All right, now the triangle method, what's that mean is many of these polygons, such as hexagons and octagons, don't have a formula. So what we do is we find the area of one, what I call an equal size triangle. All right, and then once we find the area of one of these equal sized triangles, we're going to multiply that by the number of triangles. The number of triangles in the shape, which again is really, it's the same as the number of sides of the shape. And I'll show you guys what I mean by that in a little bit here. All right, so if we look at these are all regular polygons. Again, all the sides are the same, all the angles are the same. If you notice that you can see a triangle inside each one of them. Now, what I want to show you is there's actually more than one of those equal sized triangles. There's one here, two, three. Same here. If I could draw, oops, sorry, I missed that line a little bit. There are several of those equal sized triangles. So we want to find the area of that shaded triangle and multiply by how many of those triangles are in the shape, which again is equal to the number of sides. So let's run through these real quick. If the area of one triangle is 15 inches squared, so this shaded one is 15 inches. I'll just write it over there, 15 inches. Well, then what's the area of the polygon? Well, since there's three of those triangles, we're just going to take 15 times 3, so that would be 45 square inches. All right, if this triangle was 22, well, there's 4 of those, so I would just take 22, they're all equal sized triangles, multiplied by 4. That gives me my 88 square inches. And that's really what we're doing for all these problems. Again, this is a pentagon, all right? And you'll notice that in here you can see all the number of equal sized triangles that we have. All right, 1, 2, 3, 4, 5. So there you go. Find the area of one. This is 8. All right, well, since there's 5 of those, we take 8 times 5, and that's going to equal our 40 square inches. And then the last one, again, when you connect these, you can see that this hexagon, there will be 6 of these equal sized triangles. 1, 2, 3, 4, 5, 6. Well, if one of them is 7 inches, I take my 7 inches and I multiply by how many are there? Well, there are going to be, we just said 6 of those, and that will give me my final answer. 7 times 6 is 42 square inches. So that's kind of how the technique works. Now, the trick to it is finding the area of that shaded triangle. All right, right here, which in this case is right here. So how are we going to do that? I kind of wrote some steps here. We're going to find the central angle, all right, which again is 360 divided by the number of sides. Then we're going to divide that central angle in half, all right, which is this number right here. We need that 36, okay, that's step 2, all right, for the reference angle. Once we know that, we're going to find the legs of the reference triangle using SOHCAHTOA, and then use the hypotenuse side legs to find the area of one equal sized triangle, and then multiply through. So again, here is the steps for SOHCAHTOA. If I want to find A, which is right here, I know it's the adjacent side and the opposite, so it's going to be tangent, and that gives me that value, then I can figure out the rest. So let's get to some examples right here. Regular pentagon with an apothem of 10 inches. So there it is. Now what I'm going to do first is I'm going to kind of draw in what I call my reference triangle. Okay, so we said the first thing was find the central angle. 360 divided by 5 is 72. But remember, we want to then divide that by 2 because the apothem bisects the central angle. So this right here, I'm going to zoom in just a little bit. This right here is going to be 36 inches, or 36 degrees. Okay, that's step 1. Now, in order to find the area of one equal sized triangle, which would be this whole thing, we need to figure out what this base is, which is this piece right here. I'll call that X. So using trig, we said we're going to use trig. Here's our reference angle right here. All right, this is the adjacent side, and this is the opposite side, the side we're trying to find. All right, which involves opposite adjacent, that's tangent. So I'm going to set up my tangent proportion. So we're going to say tan 36 equals the opposite, which is X, over the adjacent, which is 10. Okay, so once I cross multiply and divide, tan X is going to equal tan 36 times 10, which actually gives us about 7.3. Okay, so I'm going to erase some of this stuff here. So this x is 7.3. All right, now on my equal size triangle, okay, we've got enough information now, but I'm going to have to redraw this equal size triangle. If that's 7.3, remember the apothem bisects, so this is 7.3, so the whole thing would be 14.6. So now I've got enough information to find the area of this blue triangle right here. So let's find the area of that triangle. So that's going to be, all right, 1 base times height. The base is 14.6 times 10 divided by 2. So the area of one triangle is going to equal, that's when we end up doing that, that's going to give us about 73. So 73. Now that's the area of one of these, this triangle right here. How many triangles are there? We then take that number, the area of the polygon, which in this case is a pentagon. All right, so I'll just write area of the poly so you know what we're talking about. That's going to equal our 73, which is the area of one equal size triangle, and then we just have to multiply it by the number of those triangles in the shape. We know it's going to be 5. Again, if you're not sure, you can see me draw those here. All right, and I think I forgot one. Oops, sorry, I messed that up. But you guys can see we've got 5 of those triangles here. All right, so we're going to multiply that by 5. When we do that, our area for our polygon is going to equal, that'll end up being about 365, and then it'll be inches squared. So that's how you're going to do a problem like that. Let's take a look at another one. All right, this time it's an octagon with a radius of 6. So let's draw in the apothem, which again is kind of our reference triangle. All right, first thing we need to do is find that angle, 360 divided by 8, which is 45, but then we're going to divide that by 2 because we only need half of it. So that's going to equal, that's going to give us our, I'm going to write that here, 22.5 degrees. That's this angle right there. All right, that's 22.5. Now, in order to solve the area, I need both legs. I need the apothem and this side right here. So I'm going to call that X. I'm going to call that A, all right, for the apothem. What I'm going to do is I'm going to have to set up trig functions. So we can see our reference angle, and if I want to find x first, again, this would be the opposite side. This is the hypotenuse, and this is the adjacent SOHCAHTOA. So I want to find x, that's the opposite side, and the hypotenuse. So I got to say sine of 22.5, and that's going to equal x over the hypotenuse of 6. Put that over 1, cross multiply. So x is going to equal, when we do that, 2.3. So now I'm going to make this right here, I'm going to put a 2.3 here. All right, now I need to find the apothem. All right, to do that, I'm going to use the adjacent in the hypotenuse. So now I got to use cosine of 22.5, and I got to set that equal to adjacent, which we're calling apothem, over the hypotenuse of 6. When you cross multiply, you're going to get A equals, if I do that correctly, you're going to get 5.5. Again, put this over 1 and just cross multiply right here. A equals 5.5. So I'm going to kind of fill in our values here. So now we know that A is 5.5. And that little piece was 2.3. Well, then we know that when I have my whole equal size triangle, the base is going to be 2.3 and 2.3. So the base is going to be 4.6. And we've got our height of 5.5. So let's find the area of the one triangle. So area again equals base times height, which is, we're going to say 4.6 times 5.5. Just find the area of that equal size triangle divided by 2. When I do that, I'm going to get 12.65. That's the area of one triangle. Now, final part, to find the area of the polygon, I take our area of the one equal size triangle, the 12.65, and I multiply it by the number of those triangles in the shape. It's an octagon. There's going to be 8 of them. So we're going to multiply that by 8. And we're going to get our answer of, final answer I'll put in red here, 101.2. Again, there's 8 of those equal size triangles. You guys can see it here. There's one. Here they come. And you can see that there's 8 of them, so I'm just taking that by 8. And that's how you find the area of a polygon using the triangle method.